of a liquid surface. What is the role of this force here? To minimize force acting on the per unit length of a liquid surface, which is trying to minimize the surface area of the liquid. এটুকু বুঝতে পারলাম আমি কি বলতে চাইলাম এখানটায়?
হ্যাঁ স্যার।
যে ধরো তুমি ওয়াটার ড্রপ কেন এটা রাউন্ড মানে স্ফেরিক্যাল ইন শেপ? হোয়াই উই হ্যাভ সিন দ্য ওয়াটার ড্রপ আর অলওয়েজ ইন এ স্ফেরিক্যাল ইন শেপ? হোয়াই? Because the spherical, if some given mass of a substance have the lowest surface area in the spherical size, that means যখন ওয়াটার ড্রপটা আমার ফর্ম হচ্ছে তখন কি করছে যে এর সারফেস বরাবর যে ফোর্সটা আছে সেই ফোর্সটা কি করছে এর এটা মানে ভলিউমটাকে স্কুইজ করার চেষ্টা করছে যাতে করে সে একটা মিনিমাম সারফেস এরিয়া গেইন করতে পারে। এই যে ফোর্স অ্যাক্টিং অন দ্য সারফেস পার ইউনিট লেংথ অফ দ্য সারফেস অফ দ্য লিকুইড, ইট ইজ নোন অ্যাজ দ্য সারফেস টেনশন। ক্লিয়ার? তাহলে সারফেস টেনশন কি আমাদের সলিডের ক্ষেত্রে অ্যারাইজ হতে পারে বা কোনো সলিডের ক্ষেত্রে অ্যারাইজ হতে পারে? না, সচরাচর কেন আমাদের কমনলি যে ম্যাটার, what are the common state of matter? There are 5 state of matter, that is solid, second liquid, and third is gas, fourth is plasma, fifth is Bose-Einstein condensate. But among these 5, the most common are these 3. Solid, where the particles of a solid particle are already compactly, their force is too much high that their shape is totally compact. So there is no change. We can't change by applying any short kind of any type of force of lesser extent to change the surface area or volume of the solid. So it is we can kick out from here. Tridip Mondal, those who have joined only with their names without their IDs, please be careful, otherwise you will not get the attendance for the today's class. Those who have joined here with their only name, go out and mention your last 4 digits of student ID and come again, otherwise today's attendance will be missed. So for the gas molecules, they are totally diffuse. So the force of attraction among these gaseous molecules is much more lesser. So we can discuss from the surface tension phenomena. Only the liquids are remaining in the clause of this, or remaining to feel the surface tension forces. Let us consider it is a liquid sample. So if we are considering a molecule here, it is B. So what type of force of attraction it will feel? All the directions from this direction, from this direction, from this direction and this direction. So that means the B, the molecule B, it will be in a equilibrium or balanced state. So there is no net force of attraction in any direction. From all the directions, the force of attraction is same. But if we consider in the surface, let us consider it is the molecule A. What will happen for this molecule? For this molecule, the bulk liquid sample will try to pull in this direction. But that type of force of attraction is not possible here where the vapors or gaseous molecules are there, because the attraction is not so high. So what will happen? As a result, the surface of this area or for this particular molecule, it will be somehow minimized. It will come in downward side. So why this surface tension can minimize the surface area of a liquid? It is clear to all. Is it clear to all?
Yes, sir.
Yes, sir.
Okay. So let us come to our experiment. So what is stalagmometer? It is nothing but a glass made of equipment made up of glass, just like relatively like this, because I can draw properly here. So it has a particular volume. We have to fill that volume by some liquid, and we have to release the liquid to fall down by formation of drops. So what is the main principle? When the drops will come down from this capillary to downward side, when the mass of this drop will be the same with the surface tension which is exerted on this water or liquid drop from the circumference of this capillary. Let us consider the radius of this capillary is r. So what will be the circumference for the capillary? 2 pi r. Is there any doubt here?
No, sir.
Now the surface tension, what I have told previously, that surface tension is a force acting per unit length. So this is the circumference. So total surface tension which is exerted by this circumference, what we have to multiply here? We have to multiply the surface tension per unit length, that is designated by gamma. So that is the total surface tension exerted by the capillary surface or the liquid containing on the capillary surface, and it is equal with the mass of this water drop. So it is not possible easy to determine the mass of this each of these drop of the liquid. So what we will do? We will first fill this apparatus stalagmometer with known sample, that is water. So let us consider the density of water is dW, and the volume will be fixed, so that volume will be V, and for V volume of water, we are getting n number of drops, n1 number of drops. So the volume of each drop, V small v W equals to V N1. We can write or not? It can be written or not? It can be written or not?
Yes, sir.
Yes, sir.
So, the mass of water drop or one water drop equals to VW into dW into G. Can we write this or not?
Yes, sir.
So, this term, the total multiplied term will be equals to what? It will be equals to 2 pi r gamma W equals to WV dW dG. Can we write or not? So let us consider this is the equation 1. Up to this it is clear?
Yes, sir.
Now we will fill the volume, same volume of the stalagmometer with our experimental solution, that is the glycerol solution, aqueous glycerol solution. Here also the volume, total volume V, total volume. Total volume is V. And we are counting the drops. The starting from here to here, we are getting the V volume of the aqueous solution and counting the drops. And we are getting the number of drops here. Let us consider N2. So, in this case, the volume of each drop of the solution under investigation we are designating by Vs equals to the total volume which is passed here by the number divided by the number of the drops. Similarly, we will provide the density of this solution, or we will provide some other instrument called specific gravity bottle, from where by taking the masses you can determine the density of the aqueous glycerol solution. Otherwise, we will provide in the lab as per the protocol in the institute. Let us consider the density for this solution, that is the aqueous glycerol solution is ds. So here mass will be glycerol drop equals to V S ds into G. So we can write it V N2 ds G. Can we write or not? So this will be equals to what? The surface tension, total surface tension exerted in the capillary circumference by the solution surface, that is this. So Vs into dW into G. Let's consider that is 2. So in terms of V, if we try to express this expression or equation in terms of V, what we will get? V N2 dW, oh sorry, here it is ds into G. It is, let us consider 4. And similarly, if we try to replace this VW by V term, we will get V by N1 into dW into G. Let us consider this is equation 3. So fairly if we write, what we will get? We will get ultimately two equations in terms of total volume and number of drops counted. So for water, what we are getting? 2 pi r gamma W equals to V N1 dW G. For the experimental solution, is it clear? Ultimately, we are getting two expressions here. Now, what we will do? We will try to remove whatever the common terms here. So, what we will do? We will divide this one. Let us consider that 3 divided by 4. What we will get? 2 pi r gone. Gamma W equals to gamma S equals to dWg by ds G gone, remaining, that is N2 N1, because it is in down. So whenever we are trying to divide this equation by this, so it will flip out there. Now we have to determine this one. Gamma S equals to N1 ds N2 dW into gamma W. Is it okay or not?
Okay, sir.
So if you can count this number, D is already ds and dW we will provide, and gamma W also we will provide. So you will get the gamma S, that means the glycerol solution surface tension. Okay. Is it okay or not?
Yes, sir.
So all of you got the lab protocol, that means the experimental procedure for this experiment number 4. It is already given. So to do the experiment properly in our lab, what we have to do, we have to measure the temperature, because the surface tension also vary with the temperature vary. There are some equations, no need to remember at this moment. If you are interested, you can go through the literature where you will get that called, what is they called, Ramsay-Field equation. Ramsay-Field equation. From there we can get the relation between the surface tension and the temperature. Here you have to draw a table. No need to draw right now. Whenever you will do the experiment in the lab, already it is given in the protocols or lab procedure. I am just trying to give you the information that what you have to do in the table and what type of data you have to fill in there. So at first you have to draw a table. So here the heading will be the solution in stalagmometer. So firstly, what we will take? Water. Then the number of drops. For this water, at least you have to measure the volume, same volume, that is V. For water also, you have to run at least 3 times. Otherwise, the drop formation may be hampered, not equal. If it is taking before forming the full drop, it can counted, it can fall down. So whenever you will run the known sample water, you have to record this for at least for 3 times. Otherwise, 4 times you can perform the experiment. Then what will be the next column? It is the mean of whatever the, let us consider for the first run, for the V volume of the water sample, you are getting 30 drops, now 31 drops, now 29 or 28 drops, like that. So you have to take the mean of that. Okay. So if you getting the mean, it is around 30. Then the density of water, it will be provided at that particular temperature. Generally, in room temperature, in the lab, the temperature at that temperature, the density of the water generally it is 0.996. It is gram per cc. Yes, tell me. Somebody is trying to tell something. Who is there? If somebody is trying to tell something, now the surface tension. Force. So what is the unit of force? Anybody of you?
Newton.
Or in CGS unit, as we are using here gram, so we have to go for the CGS unit. Otherwise, we have to go for the kg per liter or meter cube. So that is dyne. All of you know. Don't be panic. Okay. Dyne per centimeter. So for water it is already known, 71.97. So it will, all this data, these two data will be provided. From the experiment you will get. Now similarly, same volume, whatever the volume in the stalagmometer you have filled by the water, same volume will be filled by the glycerol solution. So here second one is glycerol solution. Similarly, here also you have to run the experiment for 3 times. Similarly, you will get the mean of this data and density. Either we will provide that one, otherwise with the help of specific gravity bottle you have to determine. Generally we will provide. So let us consider that we are providing, and the value of this density of that particular aqueous solution of glycerol is 1.00867 gram per cc. by using that equation, the previous equation, we can determine that or not. Then let us consider gamma 1, gamma 2 equals to N2 D1 N1 D2. In this way we can determine or we can determine. Let us consider the gamma 2 we have to determine. If we apply all these parameters here, all the values of this here, we will easily get this gamma 2. Is it clear up to this?
Yes, sir.
Yes.
So this is the procedure you have to perform. Is there any doubt here? Up to this. So for this experiment, you have to use, there are few apparatus already mentioned in the lab protocols or experimental procedure leaflet, whatever the institute you have provided. The stalagmometer, distilled water, aqueous glycerol solution, specific gravity bottle for the density measurement as I am mentioning there, and weighing balance. Okay, so whenever we will do the experiment in the lab, I will show you, or ma'am will be there, she will show you how to perform the experiment. For this experiment, we have to take care some precautions. The precautions are firstly the stalagmometer will be properly cleaned. The stalagmometer, it should be, I am telling the it for the stalagmometer, should be placed vertically. And third one is, you have to be careful about the proper drop or drops formation. Fourth, whenever you are taking the reading of the volume in the stalagmometer to run a particular volume, you have to be careful with the layer of the liquid. That means for the colored solution, I have already told you during this complexometric titration that for the colored solution, whenever you are taking the bullet reading, you have to consider the upper meniscus or the solution. If the solution is colorless, then you have to take the reading of the lower meniscus of the solution. That means if it is the stalagmometer, if it is your stalagmometer and the marker is there, the label marker for the V volume is there, that means the lower meniscus should touch here, and here also the lower meniscus should touch here. For each and every run experiment, 3, 4, 6 times you have to be careful during the taking of this reading. So is it okay? You can perform the experiment by yourself if we will provide all the material to you people. Please tell me. Hello?
Yes, sir.
Okay, so For theory purpose, up to this discussion will be over here. So I will call Rosni. Rosni, have you taken the attendance?
Yes, sir.
So then you send me in my WhatsApp. All of them has included ना?
Yes, sir.
मेरा अटेंडेंस नहीं हुआ है सर.
कब आए थे
I
तुम?
have taken. I have taken.
ओके
तुम्हारा
थैंक
नाम क्या है?
सर युवराज.
युवराज. Let me check. Rosni, you have taken,
Yes, sir.
but I'm not seeing Yuvraj's name.
Sir, his name is at the last.
Okay, I got Yuvraj's name. Okay, so thank you for your attention. You can leave. And if you have any questions, you can ask. Feel free. No problem.
In offline class, will we do this experiment?